Okay, so in this video I'm going to retrieve some data about prices of certain products from my local grocery store chain, and this is because I need to know some general prices of ingredients, for example, milk, eggs, and some fruits and vegetables, so that I can actually use this data in my optimization algorithm when I'm generating a weekly menu, because we also want to have a cheap, relatively cheap menu, not something overly expensive. I was thinking about making this a parser tutorial, so I first thought that I could show how to write a parser with parsec and scrape the data from HTML, but it turns out that this is actually a single page application, and they have a really nice API that we can use or abuse, whatever you want to call it, and get all the information that we need. So, for example, let's open developer tools, and I'm just going to detach this. Okay, and I will switch over to the network tab. So if I go into a certain category, for example fruits and vegetables, and I've already inspected all of these things, I know what I'm interested in. I'm just showing you a few tricks here that you can use. So now we have all the requests that were made. As you can see, we have some images that were requested from the server, but since this is a single page application, we are interested in AJAX calls or XIJAR requests. So if we click over here, now we get all of those requests filtered. And we get a request for categories, so I guess this will give us the names of the categories. But I'm not really interested in that at this point. I'm more interested in this part over here. So if we go over to headers, we can see that this has URL of categories, then probably ID of category, and then we are requesting just the products from this category, and we want 12 products per page. And here are our request headers. So if I try to open this in a new tab, for example, you might expect to get JSON over here, but that is not the case. And if I take a look at my developer tools over here and refresh the page, and I need to switch over to all, and you can see we get this in red. So it says that it's not, our request was not accepted. And sometimes you need to try to figure out what headers you need to send to the server to actually get the response that you want. And over here you can see that we are telling the server that we accept text HTML, application XML, blah blah blah. But since this is a JSON API, we want to accept application JSON. So this is just the one thing that I had to do here to actually be able to query this JSON API. I thought that I might have to, maintain a session cookie or something, but they didn't really care about security, I guess. Okay, so yeah, now we know what we need to do with our request, and it is a GET request. As a response, we get the list of products, and we also get some information about the category in this page property. And this is quite interesting because we can get the number of, or here we can see a total number of products in a certain category. And what this means is that we can actually get all products in one request. We just need to get this item count first, and then put it over here instead of 12. So that should be quite useful. And here, it's just a list of products and JSON objects that are defining the product. And we have name, we have price, and some other properties. And I've already took note of what I'm interested in and what I will use for my calculations. So I will not worry you with this. Okay, so let's go to my code editor, and over here I've made a new section in the Cabal file, and I have defined a new executable called scraper, and this will basically be just a simple command line tool to retrieve the data from the API. Okay, and it's in the scraper folder as is defined here. This is the main module, and these are the packages that we will be using. So Wreq is a library that is allowing us to make web requests or HTTP requests or whatever, and this is what we'll use to query an API. It's a really nice library and supports a lot of things. Then we have lenses, basically just a library that allows us to more easily access deeply nested data within deeply nested structures. Then we have JSON, which is a JSON library that will help us parse JSON response that we get from the server. And then we have a lens JSON. So this is just a version of lens for JSON. Okay, so let's open the main module, and as you can see, not much over here. So what I usually like to do when I'm coding in general is just to mock the things, just to set some sort of scaffolding so that I know what I actually need. Okay, so obviously, we have in our inspector here, let me just refresh this page, like so, execjar, and yeah, so we are generally getting a JSON that represents a certain category and products within it. So obviously I will need to have some kind of function that will get this category. I'll call it getCategory. And this function will take a domain name, and this is because I actually don't want to mention consume in my code, just to be on the safe side, because if I do it without the name explicitly stated here, I can play dumb if any trouble comes my way. So let's just type in the main name, and this will be my custom data type or simple type. Just type alias so that we immediately have documentation in our functions. The next thing I want is a category ID. And then finally, I guess I want to specify how many items from this category I want. And then in the end I will maybe return a category object. And obviously, since this function will go to the internet and get JSON and return a category, this has to be within the IO monad. So I'm just going to leave this undefined for now, and I will also define other functions. There we go. So basically I will have three main functions, one for getting the category and without item count, then one for getting the item count, and the one for getting just the products. And these two will basically be just support functions for defining this main function over here that we are actually interested in. So the next thing is to define types. So let me just do this as well. There we go. And I guess it would also be a good idea to put this into a separate module. So I'll just create a new file. Whoops. Like so. There we go. And I guess I will also call in some other imports as well, just to keep things short. There we go. And I will also need a function that will generate this domain name. So let me do this as well. And this will just generate the string that will allow us to query the API. So this thing over here, and I just need to replace certain parts with the variables, or rather function arguments, like so. And I also need to define the URL. Oh, actually I already did. Great. The next thing we need to do is define category and product data types. So let me just do this as well. There we go. So I've defined both category and product data type. And here I've just made a note of fields, of JSON fields that I'm actually interested in. And I also made a note that I need to do some calculations to get the data in the proper shape that I actually want to have. And yeah, so we'll have to write instances of okay, had a small interruption. So yeah, basically we'll have to write an instance of from JSON for each of these two data types. But I guess that will come a little bit later down the line. Okay, let me first see if this actually compiles. It's always a good idea to check things before you go any further. And we have a warning, so yeah, so I've added a types module, but I didn't list it in other modules in my Cabal file. And we can put this over here. Like so. And there we go, so it built successfully. Right, so let's go and define, for example, a category first. And let me just quickly open the documentation of Wreq. There we go. So there it is. Okay, so here is the whole documentation, and we will be making GET requests, since this is how this API actually is functioning. And we have a function where we just supply the string, the URL to which we want to go, but the GET request already has certain headers set, as I've described previously. And we'll have to use getWidth function, where we can pass options that enable us to actually set some custom headers and parameters in our request. So I think we actually have some documentation on setting the headers. Yeah, I don't see it. Let's just click over here on the option and see what we can actually get from this. Okay, I think there was defaults. Oh, maybe just go back to the documentation. Ah, yeah, so here we have a defaults object. Let's just view the source. And yeah, so it already has some headers set. And I guess we could use lenses. I think I've also seen an example somewhere. Yeah, okay, so here we have a way that we can set some default options for our request. So let's go into the code, and I'm just going to define a new constant. I think I'll just call it JHeader, like JSON header, and this will be of options type. And now, since we are using lenses, we can use a setter from the lenses, and I'm assuming that we can just type in header and accept. So this is the header that we are trying to set, and the way you're actually setting, with this we are just selecting the value that we want to set, and here's how we add a new header into our request. So this should be /JSON, and if you want to set multiple headers, you can just duplicate this and rename and set different values depending on the type or whatever. Okay, but this should be just enough for my purposes here. So now we can try and actually get some data from the API. Let's open a do block, and we'll use a function get with options. So this is our options object, and now we need to pass in the URL. So for that I'll construct the URL, and I need to add parameters, domain, category, and item count, like so. And now we need to get the pure values, so we'll get the response object. And for now, let's just print this response object to the console, and I will return a nothing for now. So let's see if this works. And I guess I didn't enable overloaded strings extension. Because this is expecting text instead of a string, so let's just try to rebuild this. And okay, it builds now. So let's try our get category function in the REPL. And when you're working with multiple executables and projects, you need to be able to select which one you actually want to load. So by default, the library that we have defined in Cabal file will always be loaded, and then you can load additional modules depending on your setup. So let's say stack REPL, and now we need to define which project is the main project. So main is scraper. Okay. And you can see that we have these modules loaded from our library and from our scraper, and then now we also need to just load the main module, which is the file that we are currently working on. And let me try and get the category. So I need to know ID of the category. And yeah, okay, let's just use 68 since we already have the Right, so category 68, and let's just say 12 per page for now. And yeah, we are getting some JSON, and it appears that these are products. Let's just check the response headers. So okay, we have status code of 200 and message. Okay, so it means that server agreed to give us the data that we have requested. So the next step is getting this data and parsing it. And what we get with the response object is essentially just a byte string, so we need to decode it into JSON, and for that we can use a function that's available from the JSON called decode, and we can do something like this. So we take our response, and then we can use the lens to access the response body of our object, and you can actually see this in the Wreq documentation somewhere. Yeah, okay, so here we are getting a response status and then status code, but for our purpose we are only interested in response body, because the response body is actually this content itself. Great, so if I try to reload this now, oh, it passed. It shouldn't have passed. Huh, interesting. Let me just see if it builds. Oh, I didn't save the file, yeah. So I guess we should get an error now. Okay, so now it's telling us that we have no instance of from JSON for our category. And this basically means that Haskell does not know how to convert JSON into our category, that data type that we are returning over here. Right, so here in the types, I guess we again need to include the JSON. And now we can write an instance for the category. So let's write instance of from JSON for category. And from JSON has only one method or function or whatever you want to call it, which is parse JSON. Let me again just open the documentation of JSON. Okay, well, let me find, yeah, that's here. And yeah, so JSON basically first parses everything, just JSON first parses everything in this arbitrary object data type, which is, you know, hash map of text and a value, and a value can be an object, an array, and string, blah blah blah. But then we need to somehow convert all of these arbitrary values into an actual Haskell data types, and you know, we can pattern match this object and get the value, and then use this accessors to actually query deeper into the current value and get something out of this hash map that's named X, and use applicative to apply our custom data type and put all these values into appropriate fields within our data type. And then we also need to make sure that we catch the case in which we give to parse JSON something that isn't of type object, and then we need to report this error. And we can actually use a function called withObject, if I'm correct. Yeah, okay, so it's right here mentioned. Oh yeah, it's just over here. So basically this will just wrap the part, this error part, so that we don't have to meddle with this, and you know, it makes things a little bit more cleaner. So this is what I will use. So I basically need to just use a function with object, and then just pass the string name of our category, and now the function that we pass in the value, and it's also a do. Okay, so now let's take a look at JSON that we are retrieving. So I'm not interested in getting this whole page type, page object. I'm only interested in the item count. And to avoid creating another data type that's called page, into which we can parse this page object, we can just, for example, get the object JSON object type into a temporary variable, this thing over here, and let me do just that, like so. So here I've captured this arbitrarily defined object that's actually a DSL, some sort of syntax tree for defining JSON. It's not yet our actual data type, we need to convert it. I've just stored this into a temporary variable, and as you can see I've told that I want this page object found from my JSON over here. And now I actually want to extract the value item count from this page O object, like so. And now we also need to get the product, which is an array of product items, and we will also have to write a from JSON instance for that too, because this should be automatically handled over here. And so now we just need to return the category with this field. So item count, actually, yeah, like so, and products. So since category is defined, actually this product field is defined already here as a list of product, JSON will automatically know to convert this product's value, to try to convert actually this product's value into a list of our product items. And JSON already has an instance for the list type, so he will know how to handle this. And then we just need to also provide an instance of from JSON for our product as well. So let's do this over here. Well, actually, let me just show you quickly in the command line. Oh, I guess again we need to add overload the strings. Okay, so now you can see that we get the warning that we are missing from JSON product. So let's go and fix this. And I'm just showing you this so that you understand that JSON is smart here. When we are using this, he automatically knows what product, what type should he try to convert this value to. And again, it is the same pattern. So we don't need to worry about going through an array of things over here, because this instance will be run on the objects within the array. As I've said, JSON already knows how to handle the list, and so we just need to worry with this context over here. So basically, when we are within this instance, we are already deep within this object type. We don't have to manually go into the products array and go through every item in the array. Okay, so let me go and write this instance. Okay, so I've set everything up, and it's very basic stuff, nothing too complicated. I just have like this one price object that I need to first require, then get the amount, which is a price. So here it is. I'm always marking this JSON objects with big O at the end so that I can differentiate them from the price. And then I'm just returning a new product with the name and the list of tags. For now it's empty because it's a little bit more deeply nested data type. And you know, I do some conversion on price, the thing over here, because at the moment it's without the decimal. And I'm also doing some transformation on factor. This is something that I've noticed in their responses. I'm just you know, fixing things so that they suit my needs. So now things should build, or maybe not. Oh, I'm also missing a text price over here. Okay, so I guess it builds now. And let me just change the main. Okay, so this is already fixed. I've removed the print from here. And now I can just load main again. So I'm just going to get 5 categories, actually 5 products from category 68. And let's see what we get. So we get just category, item count 34, and the list of products, banana and lemon and blah blah blah. Okay, so everything is functioning properly. Now I have this a little bit more complex feature somewhere in here. Yeah, so I need to get the general idea about the product, you know, if it's a fruit or vegetable and whatever. And we noticed that I could use this keyword property in here from the categories, because I get you know, categories to which a certain product belongs to along with this product. So we also need to extract this data as well. And yeah, so I guess the good idea here would be to create a new data type, actually a new type, just to write the text data type in it so that we can write an instance of from JSON for this data type, like so. And this is basically what new types are mostly used for, you know, so that you can define a new instance of something for a data type that already has instance of this same thing, but you actually need it for a different purpose. And here is a simple implementation that should actually work. So now we need to change this to tag. And over here, let's get the tags. So we dot, what was the JSON, categories, like so, and tags. Okay, so everything works. Let's try this again. And sure enough, we get our tags listed in here. So I did this just to avoid, you know, unpacking this thing several times in here. And I also think it's, you know, much cleaner and more descriptive when we actually create a new type for these kind of things. Okay, so now we just need to implement a get item count function. So again, we pass in the domain, category, and that should be it. And this is monad. And you know, in here we can just say, okay, give me a category. Since category should have, you know, item count on itself. And I'll just request one product so that, you know, we don't spam a server too much. And now we just need to return whoops, like so. Now we need to return item count, And since get category, when we unpack it from the IO monad, is actually returning a maybe category, we should probably like fmap or just use applicative over our category, like so. Yeah, I guess that should be it for this part. And now we just need to implement get products, so this should be fairly straightforward. So we want to pass in the main and the category. And first of all, we want to get the number of products that we want to request from a certain category. So get item count from category, from the domain and category. And again, we would get the maybe over here because we are returning maybe item count. And let's just import a useful utility function from data maybe, and the function is called from maybe, and this is just a shorthand that we can use to immediately convert the maybe value into an actual value. So we can say from maybe, and then we give it the default value in case the second argument is nothing. And if it's not nothing, then it will return the value from the jest. So, and since we are currently here in the IO monad, let's also wrap this and partially apply it and use applicative syntax, like so. Now we need to get the category DC and then apply the number of items that we want to require, so that we actually retrieve all the products within a certain category. And since we actually want to retrieve the list of products, we have to get that field, so category and return products, and again the same thing. So let's see if this will work. Okay. And I guess we could actually write this even shorter, so we just need to map 2 times, like so, and again map over our function over here, and this would basically give us the same result. And again, we can use applicative syntax since fmap and applicative is the same thing. And let's try this out again. Okay, it works. And let's try to get all the products from a certain category. And there we go. It seems that everything is working as it should. Okay, so now it should be trivial to save this into some file or into a CSV file and use it for further inspection. And basically why I'm doing this is because I'm not interested in all the categories. I don't want to get the house appliances and food for pets or something like this. I just want to retrieve data from certain categories. So now I can just, as you can see here at the bottom, when I hover, I see that this is 262. That's the idea of categories. So I can basically just make a list of categories and then run this function over that list and get only the data from the categories that I'm actually interested in, so that I don't have to manually filter out the things. Okay, so this should be it for this video, and I hope that you've learned something new here, and see you in the next one.